Hello everyone, welcome back to the another session in Design and Analysis of Algorithms. Topic name is 0 by 1 Knapsack problem. This topic you will find in third unit as topic number 4. The topics of this video, the contents of this video is, we'll be going to talk about what is 0 by 1 Knapsack problem, and we'll apply dynamic programming approach to solve this 0 by 1 Knapsack problem using tabulation method and sets method. Started to understand what is 0 by 1 knapsack problem. So basically a knapsack is what? It's a container or it is a bag. So in this bag we wanted to place some items where, keeping in the mind the constraints are two, which is always the profit should be maximum. When you place the set of objects in this bag, the sum of all the profits of the item should be maximum. And the second is, the weight of all the items should not exceed the capacity of the bag. So we'll keep in the mind these two things and we'll find the solution for the problem. The solution is what? A solution to the knapsack problem can be obtained by making a sequence of decisions on the variables x1, x2 up to xn. So these are what the items what I wanted to place in the knapsack or in the container. So what I'm going to do is, as far as dynamic programming approach is considered, we will be going to take a sequence of decisions. That means, can I place x1 only, or can I place x1 and x2? Can I place x1, x2, x3? So we will be going to take a sequence of decisions. All these decisions are to be in line with maximum profit and not exceeding the capacity. A decision on variable xi involves determining which of the values 0 or 1 is to be assigned to it. That means we cannot place the item which is half, the way how we were done in greedy method. In greedy method, 0 by 1 knapsack problem is fractional knapsack problem. To make this capacity in the greedy method, we were taken even fractional part of the item. But whereas in the 0 by 1 knapsack problem, when you are applying dynamic programming, you cannot do fractional part. You have only the way of keeping the item, or you are not keeping the item into the container. That's it. That's what we are representing it with 0 by 1. That means 0 or 1. Item can be placed, item may not be placed. Let us assume that decisions on the xi are made in the order xn, xn minus 1, x1. So in stage wise, we'll take a decision. Following a decision on xn, we may be in one of two possible states. Capacity remaining in the knapsack is m and no profit has occurred. Or the capacity remaining is m minus wn and a profit of pn has occurred. Now, we'll take an example to place in the knapsack. The placing items are x1, x2, x3. These are what the items what I wanted to place in the container. Now my container or my knapsack, the bag capacity is m equal to 6. Now we were given with the profit and the weight. Profit should be maximum. Bag capacity should, after you place the items, bag capacity should not be exceed. So we will be keeping in the mind these two things and we'll get the solution for the problem using dynamic programming approach. Now let us think first of all what the way we will place the items. Now, so as I have the first item, think whether I can place x1 item into this bag. If I place x1 item inside the bag, what is the profit? If I place x1, I'll get the profit which is 1 and the weight is 2. So the total capacity of bag is 6. I am utilizing only 2. So still 4 capacity is left. 6 minus 2. 6 is what? M. 2 is what? Weight of particular item. That means WI. So M is 6, Wi is 2, and still 4 weight I can utilize for the next object. So I am placing x1 in the container. Now, so as you have this 4, now again go back for x2. So when you have x2, think about to place x1 and x2 inside of the bag. So already I place x1. Now, do you have any chance to place x2? Think about it. So that's what I'm writing the combinations. The first combination is no item is placed in the bag. The next is what? 0, 0, 1. That means third object is placed. This is what third object, x1, x2, x3. And second object is placed. And second and third is placed. One only the first is placed. So likewise, as I have n value is 3, how many combinations I'll get? 8 combinations I'll get. That means 2 cube combinations. 3 is your n value. That means 2 power n combinations will get. That is the time complexity is big O of 2 power n. So this is what the complexity placing of item inside of the container with these 3 size, right? Now we will apply dynamic programming. Half the way we will make items inside of the bag. So now I'm taking some example. I'm taking